Okay, so assuming everyone can see this tab.
Yes.
Yep.
Okay, so my talk is based on something called custom OIDC claims for Azure authentication. And yeah, my name is Anand. Let's go on. Yeah, so you guys might be wondering, what is OpenID Connect and what are subject claims? So OIDC is it's like a identity layer that's built on top of OAuth, and it's used for authenticating users and applications. And claims and the kind of claims we're going to be talking about, subject claims, are basically these key value pairs which are included within a ID token that's presented to, I guess, the entity that will be granting tokens. And these claims can either be standard or custom. So generally, how OIDC is set up in GitHub workflows is as follows. Usually, GitHub configures some kind of OIDC provider in which is issuing these tokens. In this case, since we're trying to get access to Azure, it will be Azure AD. And afterwards, within a GitHub workflow run, the workflow or the runner will present an ID token to the token provider, and it will request it from this token provider. And then Azure AD will look at this ID token, just verify a few things, and then presents a access token that this GitHub runner can use to access resources in Azure. And so when the workflow is presenting this ID token to the token provider, Azure in this case, it can add certain things to it. Some of those things we'll see are called subject claims. All right, so these are the default subject claims that Azure provides. Basically, it's like the repo followed by a reference, like the reference to the branch or the tag, or sometimes the environment, like for example, like the dev environment or a prod environment, and like a pull request. And these are some of the problems with the default claims that GitHub provides and allows, or Azure allows us to configure. So it's kind of tedious. The way that it's currently set up on Azure, you have to create a federated credential for each repo that you want to set up auth for. And these managed identities and Active Directory applications only support 20 credentials. So that means, if you have more than 20 repos, you have to, create new managed identities or AD applications. And each of those identities use different client IDs. So some of your repos might use different client IDs, and it's kind of a mess sometimes. And another issue is specificity. So once a credential is configured, any workflow in that repo can obtain tokens. So for example, you might want to restrict a very specific workflow to obtain tokens, and you can't really do that with the default subject claims. And another thing is security. You can't enforce a specific environment in which to run these workflows. So for example, on PairPath's environment, we are sort of locked down and we only want to run these Terraform workflows on our self-hosted runners. In case there's like a GitHub runner compromise, since we manage our own self-hosted runners. And you can't really do that with the default subject claims. Hello?
Yep, we can hear you.
We can hear you.
Okay. All right. So some examples of these custom subject claims. The actor, which would be like the person that's actually kicking off the workflow. Job workflow ref, which refers to the name of the workflow that's running. repository visibility, which might be something like, is it a private repo, internal repo, or public repo? And then runner environment, which might be one of the GitHub hosted runners, like Ubuntu latest or Mac OS latest, or self-hosted even. And there's a link here where if you click it, you'll see a comprehensive list of all the custom subject claims that you can give or configure. Okay, so how is this done? Basically, you have two options. You can configure custom subject claims for each repo, or you can do it for the whole organization as a whole if you want to standardize how it works in your org. And the way that it's configured is, unfortunately, you can't use any sort of settings tab or settings window in the GitHub dashboard. You have to do it using the GitHub API. My recommendation is to use the GitHub CLI since it abstracts certain things away. And you can also just use like a curl command. And there's a link here which provides a reference to the REST API endpoints. So this is Parapath's custom subject claims configuration. So the claim keys that we send to Azure are job, workflow ref, repository owner, repository visibility, and runner environment. And this long string that we have here is what we've configured on Azure. And basically what it means is we only want to allow Terraform runs using a specific workflow on the main branch where the organization is Parapath, and it's run in an internal repo, and it's also run on a self-hosted runner. So if these conditions are not met, then Azure will not issue a token to access resources. All right, and demo time. For this demo, I've created a repo which is configured to access Azure in a GitHub workflow. And the way that it's currently configured is that it will allow any workflow to run or access Azure resources as long as it's from this repo and uses the dev environment. And suppose that we want to restrict the workflow a little bit where we want it to be any workflow in the above repo in the dev environment, but the repo has to be private. Maybe, for example, like maybe we have some logs that should really be private and we don't really want those logs to be visible to the public. All right, so let's go to this link. So when I first configured it, we'll see this workflow run. So let me just show you guys the workflow. It's basically pretty simple. I've configured the environment, and then I use a GitHub action to do the whole Azure login. And so if we look at the runs here, you'll see when you expand this that the subject claim it presents to Azure is of this format. So nothing to do with private internal repos and stuff like that. So I've gone ahead and reconfigured the repo to send a different set of claim keys. And I've also reconfigured the managed identity to accept this subject claim. So as you can see, it's like the repo, the environment, and the repository visibility, and it's private. And so when I did that, I reran the workflow, and because the repo is public, it actually fails. So you can see here that it says that there's no managed identity for that subject that we presented because the current claim key it's sending, the value of the claim key is public. And so let's try to fix this by changing this repo to a private repo. And rerunning this action.
I'm sorry, is it me? I'm still seeing the Azure screen.
Oh, oops.
Yeah, me too. There we go.
Okay, thank you.
All right. So this was the workflow that I ran where I haven't changed the repo's visibility. So you can see here for that claim key repository visibility, it's currently sending a string of public, which our Azure federated credential is not set up with. So now I've gone into the settings and changed this repo visibility to private. And now I've rerun this action and we can see, well, the demo gods are nice to us.
If you hit the little triangle next to 1, it'll give you more.
Which one?
Next to the line 1 where it says run.
Oh, yeah.
Oh, it's just a waiting game. This is normal.
Okay. Let me try rerunning it.
Demos work perfectly when you're by yourself, and then when you're in front of people.
Yeah,
Yep.
exactly.
Yeah, when it tries to clear all the accounts off the runner, it just takes forever. It's just is one of the things that you'll catch with it because it does like a pre to get rid of, and then it's like, okay, now I can log in.
Oh man. Oh, okay, this one worked. Okay, so now you see that the claim that's presented to Azure is now this claim key repository visibility is private, and Azure will accept that. It grants the token, and we've successfully logged into Azure. And that's it. We've so for our org payer path, we were kind of tired of configuring so many federated tokens. I think we had almost 40 repos. And the way that we've configured like the client IDs, we sort of made it in kind of a more modular approach where we just send, we use a module to send the environment code, and then from the environment code, we get the client ID. And to have that work, we wanted just a single federated credential, or just at least a single managed identity. And the way that we did that was through custom OIDC claims. So now instead of having, 3 different managed identities and 60 federated credentials, we only have 1 managed identity and 1 federated credential. And yeah, that's it.
Over to Shannon with diagrams as code. Thank you, Shannon.
You bet. So, what kind of got me on this track? Like where did I get involved in this? Is someone likes to script and code and absolutely hates making diagrams, even though I know it's part of my role. The other piece of this is like I got to thinking about like I wonder if I could do this in code somewhere. Does Draw.io allow me to do this? Could I automate Draw.io? And that's what got me thinking about it, which ended up in an evening or 2 of rabbit holes and a lot of reading. So that's how I got to this. To that end, we'll dive right in. So what is diagram as code? Basically, the idea is that you have an approach to diagramming that requires you to represent the way that diagram should look as a code artifact, rather than creating that representation of ideas as in a visual form. You get to define the way it looks in text form, right? The key for me on this is like I loved it, like if I've got to make a diagram, Draw.io is my go-to. I know that tends to be kind of a an industry standard. I don't know about you guys, but sometimes dragging things around in Draw.io is just like the bane of my existence, just trying to get a pinpoint on something and move it, where I want it and lining it up. And I spend more time trying to make it look right than I do actually worrying about the content. And sometimes that's a lot of time that you waste on just trying to make it look presentable, or you're like, oh, I just want this arrow to go this way. How do I get it to do that? Well, that's kind of where diagram as code comes in, right? And so we look at the benefits, it's faster and easier. The layout, the positioning, etc. That's all handled by the code. The code will generate all of that for you. It allows you to focus on the content. Once again, I already commented, about how it looks, what's the alignment look like? Is this one centered and etc. The other point is too that if you ever want to do maintenance of any of your diagrams, certainly search and replace in kind of cut copy and editing sections, and you're done. It's not drag around and oh man, I added this or I need to change that, and now I have to go back and realign everything. So it can make for easier maintenance down the road. And then even though spelled wrong, we have consistency across teams. So if you have everyone using diagram as code and it's the same tool, if everyone was using the exact same tooling, then of course editing and working on those across teams would be of interest, because everyone would have an understanding, be like, oh, I need to edit this, I'll just plug it in here. I already understand how this code works, that kind of thing. I put a couple of discussions in here on from Reddit that I still have pulled up in my browser on my personal machine. I was like, yep, that's the ones that got me started. So you guys can go do a little reading and see what other people had as far as other tools and their thoughts around diagrams as code. So there's a few popular frameworks out there. There's, and I'm just kind of highlighting these just to give you some ideas, right? I've used GraphViz even before diving into this at a previous employer. I used it to map an entire database to show what applications were feeding and pulling data from each other. And it was all in a database to show those relationships. So I actually used GraphViz to go in and find those relationships and map them out. So you can kind of see a little bit of how, those graphs, these are just a couple examples off GraphViz website, and those are all, of course, code generated. Plant UML is a little bit different. It's more focused on, as it says here, the domain of user stories and unified modeling language modeling. So the layouts generated are more aligned to more of like the user, if you will. And it's kind of interesting, you can see here, you can see the differentials between them in terms of the types of diagrams they'll generate. Like the plant UML and the next one we're going to talk about, which is Mermaid, are definitely more geared at what I would call today's types of diagrams, but the GraphViz is more relational, if anything. But the nice thing about Plant UML is it's the other two are generally more modeling based, whereas this is more of a drawing based. And I snagged their examples off their website for this as well. And you can kind of see here how simplistic it is. This would take me a few minutes to draw. Don't get me wrong, it's not that complicated, right? But it's certainly easier to just put Bob points to Alice and Alice is pointing to Bob, and here's your request and your response. Instead of me having to align and all that, this has all just been generated. Behind that, we have Mermaid, which is newer. And it kind of splits those, like that says it's gives the idea of a subset of functionality from the other tools, but streamlining it. And you can kind of see here again, it's a very similar idea of being, different language, different outputs, but the idea is very similar, right? And so, A is connected to C, and we have this round rectangle, so that's describing the type of shapes and whatnot. And I'm not going to dive too deep into the intricacies of each. The idea is to give you an idea of how we're going to take and diagram something in code. But there's certainly different languages and different choices. And a lot of it depends on the need and what you're diagramming. Some are better at certain types of diagrams than others. So when I got into this and I started kind of deep diving into all this, I ended up looking at two of them very closely based on what I wanted to diagram for our team. D2, which I've left a link to, is declarative diagramming. And the other one that I looked at is Eraser.io, which is a little bit different than any of them out there. D2 is totally open source and free. You can install that local and you're ready to rock and roll. The Eraser.io is free for up to 5 diagrams, but at $10 a month, I think it's very reasonable for that kind of cost. the one thing I will say that I did like about Eraser is that kind of lent itself a little bit better is it's a little bit prettier. You get to put in your own icons if you need to, that kind of thing. But it also exports a link to an SVG, which will embed nicely into Confluence. So I thought that was kind of interesting when you look at that. So we're going to go demo this off. Does anyone have any questions before I start demoing? All right. So let me close this out. Get rid of these. And I'm going to start with, this is VS Code running the D2 Lang compiler. And so what it does, it actually has a preview mode, which is really nice. So it makes it nice for whenever you want to end up showing, what you're building on the fly. And diagrams in this language could be as simple as, like, I just had a hi here, to now we're going to look at what it's like to say X to Y with a hello world in between. And in thinking about diagramming this type of stuff, of course, I could have a VM here and a gateway there and a different shape, and change this from hello world to the VPN name or an IP address or whatever, right? And that's even though this is extremely simplistic, you can see the speed in what we're doing here, right? And so I just took some examples out of the D2 webpage this morning just so you could see it on the fly, and we'll let it. So there is, I'm a shape, and I'm a shape, and I'm a shape, and a shape, just in different texting. And you can talk about, as far as the text language, what it accepts, what it doesn't accept, that type of thing. They were just giving you some examples there, right? But in this case, if I wanted to do something a little bit more involved, now we have, here's, our SQL and a cloud and a SQLite and Cassandra, just giving the idea that you can change those shapes and the naming, etc. And like I said, I'm just giving you fast examples here, just so you can see how quick it takes to do some diagramming with this stuff. So if we're going to let this come together, once again, a left-right arrow just pointing bi-directional, pretty straightforward. And you have something like this. One way. And then another example from their site. Just X and Z, pretty straightforward stuff. And then we could do something along these lines, which now we can start getting more complicated. So now that's the idea of being able to show some of your directional backups, or what path you might be taking over a network, something along those lines. And then we can do something along these lines. I'm not going to bore you with too many more demos. I just want to give an idea of how fast it is to do something inside of D2. So here's, you can look at your high mem, high CPU, who it's hosted by, EC2s, so you can branch this out fairly easily. And then if you really want to get interesting, which I enjoyed, I thought was neat when I started looking into D2, they will even do container type work. So if you're going to document Kubernetes or something along those lines, kind of gives you the idea of how you might do something along that line. So the one thing with the thing is with this, you can get it as complicated as you want. You can have as many shapes as you want. The thing I found with D2, it's open source. I wouldn't say that it's being maintained heavily, at least not when I was looking at it. But it's pretty basic in terms of, you get shapes, color, etc. But there's not a lot to definitively choose from out of the gate. It's a, you've seen a lot of stuff we've been pulling up are boxes and, maybe a cloud or something along those lines. And they have quite a few to choose from, but it's not extensive in terms of icons or something along those lines, right? So I just thought I'd give you just kind of a demo of just what D2 looks like. But now we're going to turn around, we'll take a look at Eraser.io, which I have pulled up here. And one of the things I've worked on, you guys have heard me talk about in other meetings, is we have this RPA infrastructure. And so I was like, I wonder what it would look like to diagram that. And this is me doing it by hand, but I certainly didn't drag this out. And if you look at the editor that you see here, this is all pretty straightforward stuff. It's like here's a title. By the way, I want this background to be blue, and here's a storage account. And inside that storage account, I wanted to use the Azure Blob storage icons, etc. Right? I mean, this is pretty straightforward stuff you're looking at here. The thing that makes Eraser.io more interesting to me is the fact that not only do you get standard issue kind of icons, or you can upload your own if you're paid or whatever, but I like how they do the connections. You can actually just make a connection block, and as long as you know what the names are, you can just sit down here and just be like, oh, this is a one-way connection going left or right, or it's bidirectional, so long as I know the object that I created up above. So in this case, if you look, I have a Packer VNet that was shown as an Azure Virtual Network icon. It has this particular information inside that VNet, so I'm able to show the NSG is a one-way connection to that VNet. And it's kind of nice being able to just be like, oh, I need to come down here and change a connection or add or remove or whatever without having to go through all the actual objects, which I thought was a little bit more interesting than D2. Now, the thing is that I didn't lay any of this out. And I know for a fact that if I did this with Draw.io, it would have taken me some time, just because I'm very OCD about how things look, right? Like everything for me has to be symmetrical. And I would have been working on that forever. I literally generated this with that code you saw that I input into that, and this is what I got. And that's a very presentable diagram to throw back in Confluence for a project you're working on, etc. Right? But you'll notice that the key takeaway of this meeting was not only that we talked about code as I'm sorry, a diagram as code. I apologize. I was like, I wonder if I could automate this. Like, how would it look like if I was able to come back and say, well, gather up all the NSGs for me, gather up the storage account, and now build that out. So I actually wrote a proof of concept to do that with the exact same scenario, the RPA infrastructure. And I was like, I wonder what it would look like if I just, worked it out and tried to recreate that diagram so that I didn't even have to code it. And so I have kind of a stub built out right now. I haven't had time to get back and finish up every last detail. But what I did is I looked at it and was like, I'm just going to create PowerShell code that will generate the Eraser.io code for me by looking at all the information inside of that resource group and pulling all the objects, right? And so, I'm looking at storage blocks and VNet blocks and PIP blocks, etc. And what I do is I have a function for every type of object that I want to go generate the code for. And then basically I just kind of put all of it back together, kind of working from, the outside in or the inside out, however you want to look at it. But the idea is that I'm like, okay, I know all these storage blobs are inside of a storage account, which that storage account is on, inside this area, etc. So this is just some PowerShell that I wrote that basically generates that code on the fly. And the interesting part of this that I kind of want you to note is how fast this comes back. So it's going out, it's already pulled all of that information. And if I come in here and I edit this particular file, and I'm like, you know what, I'm done with that diagram, and I'm just going to paste, in the time that code ran to now is what you saw me do to generate just that part of the same RPA infrastructure. And I don't know about you guys, but that's way faster than me with Draw.io. And the idea of being able to code something like that and generate this, but this code is exactly the same that we have in the other one. It's just I haven't written the connections yet because I have to write that code. But you can see it's all generated on the fly. And this is, if I go back and I pull this, this will all be the same, except I'm using the names of what I found instead of me putting in like storage account. This is obviously a storage account, that type of thing. So, I would love to finish this out. I just haven't had time to get back to it, but the idea is there and you can see, where I'm headed with it. So I think that's about all I've got on it. I'll answer any questions I can, but that's kind of the quick demo I had for you.
Have you
That
tried
was
to integrate
so-
any of this with Confluence pages? Put the diagrams on a wiki?
So you can't. So unless I'm wrong, Confluence doesn't support anything except for Mermaid Markdown, which I didn't pursue, But what I do like about this is when you generate this, you can actually take this and you can pull it into Confluence as an SVG link. So say, and that's the exact one that's coming out of Eraser.io. They actually give you a link. And so as I generate them, I can just post the link. And then as I change that document in Eraser, it will update here when someone loads it. So that kind of, hopefully that answers your question, Kevin, a little bit.
Yeah. So let's just pretend you want to update that diagram. How would you do that?
So for me, in this case, because Eraser.io is hosting this, right? So if I come in here and we decide to edit this, and at the top I'll be like, and then we're going to be, now if we go back over and we refresh, that should have, and it didn't. That's what I would have expected. I'd have to test that theory. I haven't really tried doing that other than putting it in, but I know that that's pulled unless the link changed. So let's see if maybe the link did. I'll see it did, but when I edited, so at some point it's probably going to update. The question is, because I didn't change the link. I don't know if it has to take a snapshot of the SVG and then embed it, but I wouldn't expect as such. But yeah, you can see it, at least that's how it was done in this case. Now, it's my understanding that Confluence does support mermaid-driven diagramming, which you could certainly generate with any of the tools that we've discussed, except for probably Eraser. I think D2 supports that out of the gate. If not, I want to say there may also be some Plant UML that may be supported by Confluence, but there would have it. Basically, those are Markdown, which Confluence will consume and render by default, is how I understand it. To fully answer your question, Kevin.
Okay, cool.
But the idea from my point of view of being able to programmatically diagram some of this stuff, and it certainly do it with script and generate the code to build the diagram. I mean, that's, for me, that's a rabbit hole. Like I could spend all day doing that and I could see the end game in it. And I want to continue to drive it. I just haven't had the time, but maybe this will give some other people some ideas on how, you might do something similar for some of your diagramming. I'd love to see us come together as as an organization and say, we either use Dry.io, or if you want to do diagram as code, you can do this, and maybe everyone get tooled up on both sides, so that documentation will become kind of very similar across teams. But that's just my 2 cents on it. Any other questions or comments? Sweet. Well, as always, thanks for the time. Hope it didn't run too long on it for you.
No, that was
Awesome.
perfect. Thank you, Shannon. Thank you, Anand. We really appreciate it. Sharing this information is so useful for everyone. And if anyone has any ideas of stuff they'd like to talk about, please approach us. We have no one set up for next month, and we would love to keep doing this conference series.
Absolutely. Thank you, everyone. Appreciate your time today.
Happy Friday.
Happy
Thank
Friday.
you.
Thanks, guys.
Thanks, everyone.
Thank you, Shannon. Thank you, everyone. Bye-bye.
Thank you, everyone.